Hello student, now we consider the case if there are repeated poles are there. Okay. So see, if repeated poles are there, so see for multiple real poles in the left half of S-plane, impulse response is of the form of like this. This means A1 plus A2t into e to the power minus at. Okay. Here the exponential time function decreases faster than the linearly increasing time factor. The response ultimately dies out. Okay. Now, if the repeated real poles lie in the right half of S-plane, the response is of the form of A1 plus A2t into e to the power at. Okay. So, in this case, the response increases exponentially without bound. Okay, if repeated real poles lie in the right half of S-plane. Now, if repeated poles on the imaginary axis, then the response function is of the form of A1 cos omega t plus phi 1 into phi 1 plus A2t cos omega t plus phi 2. Okay. Here the first term on the right hand side is a sustained oscillatory function and the second term is a modulated oscillatory function that increases with time. Therefore, the response is unbounded. So, from the above discussion, we can conclude like this: if all the roots which have non-zero real parts contribute a multiplying factor e to the power at to the response. Okay. So, if all the roots which have non-zero real parts contribute a multiplying factor e to the power at to the response. Okay. Now, if this a less than 0, then the response e to the power at vanishes as t tends to infinity. Okay. Now, if this a greater than 0, then the response term e to the power at increases without limits. If repeated poles on j omega axis also contribute the term that increases without bound as t tends to infinity. Okay. So, from the above discussion, we can say this: if all the roots of the characteristics equation lie in the left half of S-plane, that means if it have negative real parts, then the impulse response is bounded. Okay, bounded means the system is stable. Okay. And otherwise, if the roots have positive real parts, then the impulse response is unbounded. Therefore, our system in that case, our system is unstable. Okay. Next, if the characteristics equation has non-repeated roots on j omega axis, then the impulse response is sustained oscillatory. Okay. And the system is unstable. Okay. And if the characteristics equation has one or more repeated roots on j omega axis, then the impulse response is unbounded and the system is unstable. Okay. So, see, to test the stability of a system, first of all, find the roots of the characteristics equation and then apply the following rules. So, first check if all the roots of the characteristics equation lie in the left half of S-plane, then the system is stable. Second is, if any one of the roots of the characteristics equation lies in the right half of the S-plane, then the system is unstable. Third is, if rule 1 is satisfied except for the presence of one or more non-repeated roots on the imaginary axis in the S-plane, then the system is marginally stable. And last one is, if the characteristics equation has repeated roots on the j omega axis, then the system is unbounded and unstable. So in this way we can test the stability of a system. So for testing the stability of a system, first of all find the roots of the characteristics equation and then apply these rules. Okay, thank you.